So for the first question, it says draw any pentagon, 5-sided polygon, and label one of its vertex A. So again, all you have to do is to draw a 5-sided polygon. So 1, 2, 3, 4, 5. And then, so that was part A done. Part B says draw in the diagonals from A. So again, last part still from number A, we had to call one of the vertices A. I'm going to just call this vertex A. And now we've drawn diagonals. So from A, we can connect to here, that's one diagonal. And then we also connect to here, that's another diagonal. So these are our diagonals. Now this is B done, so that's all we have to do for B, draw on these diagonals. And then for C, it says find the interior angle sum of the pentagon. And so if you look at this, you can see that, for example, the shaded area right here, this is a triangle. So is a shaded area here, that's not a triangle. And so is the middle one, that's also a triangle. So we actually have, this actual pentagon has 3 triangles. Now what do you know about the sum of an area of the triangles? The degrees, how many degrees does one triangle have? So one triangle will always have to sum up to 180. So we know that one triangle is 180. So if we want to try see how much this one has, how many the interior angles add up to this, all we have to do is times how many triangles it has. So it has 1, 2, 3 triangles. So 180 times 3, and that would be 360, 540. So in this case, the sum of all of the angles is 540 degrees. For this question, all we have to do is we have to fill in this actual table. The last one we did in the last video, which was pentagon had 5 sides. Remember, it had 3 triangles. So what we could do is to find the sum of all the angles, we do 3 times 180, because we have 3 triangles and each triangle had 180 degrees, and that means that's 540. So 540 for a pentagon. Now a hexagon, I'm going to do the hexagon next. Hexagon has 6 sides. Hex means 6. So I'm going to draw one. 1, 2, 3, 4, 5, 6. The next part would be to draw in the diagonals. Remember, we take one point, call that point A. From there we draw diagonals. So 1 diagonal, 2 diagonals, 3 diagonals. And then we actually count the amount of triangles. So this here would be a triangle, this would be a triangle, this would be a triangle, and this would be a triangle. So we have 1, 2, 3, 4 triangles in this one. So we've got number of triangles 4. So remember, if we want to get the angle sum of all of the actual angles, we have 4 times 180, because we have 4 triangles, they all add up to 180 each. So that means total would be 720 degrees for this one. The next one, it already says how many triangles it has. It has 5. So all we have to do is 5 times 180, which would be 900. Now actually in the book, they actually made a mistake. They wrote down 5 times 180, but that's not true. Because if we look at an octagon, and we'll do an octagon, so an octagon has 8 sides, oct means 8. So 1, 2, 3, 4, 5, 6, 7, 8. That's roughly an octagon. Again, we take a vertex, so it's called this vertex A, and we draw on diagonals. So there, 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 and there. These are the diagonals. And then how many triangles do we have? This would be a triangle. Like, obviously it's not fully straight, but it would be a triangle if you checked. This is a triangle, this is a triangle, this is a triangle, this is a triangle, and that's a triangle. So we have 1, 2, 3, 4, 5, 6 triangles. So its number of triangles would be 6. And then to get the actual angle sum, we do 6 times 180, which would be 1080 degrees. So in this case, the book has it wrong, and this would be the result. Now all we have to do for this is complete the sentence. It says the sum of the measure of the interior angles of any n-sided polygon is what times 180. So in this case, remember, n is the number of sides, and if you look at the pattern, it was always n minus 2 times 180. So for example, if we have, let's say, a pentagon had 5 sides, so 5 minus 2, that would get you the amount of triangles. So a pentagon had 3 triangles, then we times that 3 by 180, and we would get the actual angles, which would have been 540. And this formula will be true for every single polygon. So n minus 2 in brackets times 180 is how we can get all of the sum of the interior angles for different types of shapes, different types of polygons.